Good afternoon. I'm Jay Scott, Editor Emeritus of ASHRAE Journal. Thank you for joining us for today's webinar, part of the Journal Supplier webinar series, providing information to readers and others about products and technology for industry professionals. ASHRAE does not review supplier webinar presentations. Mitsubishi Electric Trane HVAC US presents today's webinar, Reducing Costs and Achieving Value with VRF Systems. Today's presenters are James DeBerry, Commercial Marketing Manager, and Tom Greco, Director, Solutions Business Development for Mitsubishi Electric Trane. James develops and executes marketing plans for commercial new product launches and existing product maintenance. With extensive corporate marketing experience, James most recently served as Senior Marketing Manager at AT&T Atlanta. Tom's engineering background, sales experience, and over 10 years in the commercial HVAC field have given him a broad understanding of the industry. Tom began his career as an automation engineer and transitioned to commercial HVAC applications and sales roles. With both technical and customer-facing experience, he is able to effectively manage teams and help implement new technologies. And now we turn the webinar over to James. Thank you.
Thank you, Jay. Good morning, good afternoon, everyone, depending on where you're calling in from today, and welcome to today's webinar entitled Reducing Costs and Achieving Value with VRF Systems. On behalf of Tom Greco, I'd like to thank you for the time you've chosen to invest in today's session and believe you'll find the content presented to be quite valuable. We're planning to spend the next hour discussing VRF, or Variable Refrigerant Flow technology, and explore some solutions for today's commercial marketplace. Tom and I look forward to sharing our thoughts on VRF technology and some of the characteristics and advantages it offers for building owners, engineers, and others. And we'll also share some successful case studies and some additional resources for continued learning. We'll have time at the end of the presentation to address as many questions as possible. So please feel free to use the Q&A functionality within the presentation software to submit your questions. With that, let's talk about today's learning objectives. We'll explain how modern construction, decarbonization, and rising energy costs drive the popularity of VRF technology. We'll describe how the characteristics of HVAC systems affect building requirements and total first costs. We'll explain how the characteristics of VRF systems enable owners to reduce and avoid costs. And lastly, we'll explain how VRF systems create competitive advantages for building owners. It's no secret that our buildings are rapidly changing and becoming more sophisticated than ever, with one of the issues being rising energy costs. Both the country and the economy are taking notice of the need to significantly reduce dependence on fossil fuels. Strategic electrification and decarbonization efforts are on the rise, and many developers have to consider the rising cost of electricity, as well as modern construction requirements that shape the way they build and retrofit their buildings. At the same time, building owners, developers, and facility managers understand that the industry is changing, but they also have competing priorities. Policy mandates are a big driver for building updates and new construction requirements. For example, California's Energy Efficiency Strategic Plan requires all new commercial construction to be zero net energy by 2030. On the East Coast, New York City's Local Law 97 sets CO2 emission intensity limits for large properties. Building owners can face financial implications if the CO2 emissions exceed the established benchmarks. Utility companies are also getting in on these changes, offering incentives for building owners who adopt energy-efficient mechanical systems and building materials. Owners are cognizant of operational costs as well. Lastly, tenant experience and comfort remain a huge priority for developers and building owners. You can have all the bells and whistles, meet all the green certifications, but if your building isn't comfortable or can't provide cost efficiency, tenants simply won't rent the space. So that leads us to this challenge that many developers and builders are facing right now. Buildings need to be built or upgraded to become more efficient, driven by policy, utility costs, and tenant expectations. That comes with a price tag, and they want to make sure their investment will bring a return and offer savings. While many in the industry view VRF systems as a great electric run technology, they can still be perceived as somewhat expensive. By the end of this presentation, we plan to dispel that notion. I'd like to spend a little bit of time talking about what VRF technology is. Variable refrigerant flow technology was introduced into the United States over 15 years ago after many decades of prominence throughout the rest of the world. In fact, in Europe, it accounts for over 80% of the HVAC market. Today, we hope to show you that VRF technology can be a true solution for modern challenges building owners, engineers, developers, and others face. You'll be able to explain to a developer or building owner how they can install a premium VRF system at a total cost that is similar to or lower than the cost they would pay for a less efficient conventional system. There is a push towards retrofitting and developing commercial buildings with electric run VRF technology. In the commercial space, VRF is becoming more and more preferred over traditional HVAC systems, PTACs, centralized air systems for a variety of reasons. Though overall the systems align with the industry's and developers' priorities due to being electric powered, they're also flexible in design and cost efficiency. Before we jump into all the benefits, let's review how this technology actually works. At its most basic, VRF systems consist of an outdoor unit or compressor connected to a network of indoor units. Indoor units can be ducted, ductless, or a combination and offer a variety of layout configurations for a building. VRF systems heat and cool zones by moving conditioned refrigerant through small diameter piping. As mentioned earlier, VRF systems are electric powered and don't require fossil fuel combustion. In contrast to VRF operation, conventional HVAC systems typically take a centralized approach where ductwork is connected to a centrally located air handler. Here are some key issues with that. The more ductwork you have, the more potential you have for air leakage, costing you efficiency. When there is an issue with the system, the extra ductwork can make it more difficult for contractors to pinpoint the exact problem. Now, as we'll see in just a minute in the next slide, the conventional method of on or off approach means that when a set point is reached, conventional systems turn off until a temperature threshold is met, which is extremely inefficient. Now, certain conventional systems such as PTACs or packaged terminal air conditioners that are typically found in some hotels and are self-contained HVAC systems. These systems can have their own cost-related issues, not to mention they aren't aesthetically pleasing and can sometimes be very noisy. Let's talk a little bit about conventional versus VRF operations. While sized to meet design temperatures, each VRF outdoor unit has an inverter-driven compressor, enabling the system to vary capacity to match the current load. The system only uses the precise amount of energy to meet the desired set point. This saves money and reduces energy consumption by up to 40% compared to conventional fixed capacity systems during shoulder seasons such as spring and fall. You'll also notice that VRF systems don't have the energy-intensive start and stop cycles that conventional equipment does, as shown by the graphic on this slide. Conventional systems use a fixed-speed compressor which cycles the unit on and off whenever the room dips below desired temperatures. That's depicted by the gray line here. This type of system relies on an all-or-nothing philosophy with the compressor running at either 0 or 100%. This can lead to unpleasant temperature swings as the system strains to maintain a constant temperature. Inverter compressors, on the other hand, are always running in the background, adjusting the compressor and modulating the speed in real time. That's represented by the red line here. By ramping up power to the compressor when needed, an inverter provides a more accurate, on-demand approach to temperature control. If your room's temperature already a comfortable 72 degrees, for example, an inverter may slow the compressor's engine to a crawl. If your room is really warm, say 85 degrees, the inverter will push the compressor into high gear, reducing that temperature more quickly. This is another source of energy savings, as this eliminates the energy-intensive start and stop cycles of conventional HVAC systems. Now let's talk a little bit about system types. In single zone applications and in moderate climate, HVAC contractors typically install VRF heat pumps. Heat pumps are effective when all of a building zones can be in the same mode at the same time, either heating or cooling. With these systems, indoor units are either in all cooling mode or all heating mode. So in this example, on the top you can see a scenario where all the indoor units are in heat mode, and on the bottom is an example of all units being in the cooling mode. With heat recovery systems, they offer cooling operation and heating operation simultaneously within the same system. VRF systems with heat recovery are the ideal choice for office buildings, hotels, and any other facility with diverse comfort needs. These systems use a branch circuit controller to direct refrigerant based on the conditioning needs of a particular zone, whether it be heating or cooling. Heat recovery allows for less system reliance on the outdoor units, meaning less energy is needed overall. With a heat recovery system, it does allow you to simultaneously heat and cool different zones within a building. So here you can see the outdoor unit again on the left, connected to a variety of indoor units. But you can also see the depiction of the blue and red lines that some areas are in heating mode and some are in utilizing cooling. So how does this all work? This is accomplished with the use of the branch circuit or BC controller, which you can see there just to the right of the outdoor unit. One way to look at the BC controller is like a quarterback or a decision maker. By using a liquid gas separator, the BC controller separates the refrigerant so that some areas are cooled and some are heated. So each area or zone has its own indoor unit that provides heating and cooling. Another helpful feature of VRF systems is the variety of equipment options. Some of the indoor unit options include the ceiling cassette that you see here, but also floor-mounted, wall-mounted, and other options. VRF equipment is very compact, space-saving, and offering a variety of aesthetic choices. You can also combine ducted or ductless indoor units for a hybrid system. So now that we've fully explained how VRF technology operates, I'll turn the presentation over to Tom, who will go into detail on other ways these systems provide significant savings for developers and building owners. Tom?
Thanks, James. That was excellent. So as James said, let's get into some of the reduced first cost scenarios that we see with VRF systems. Avoiding first costs. Let's address something that I'm sure many of you are thinking. You've probably been told at some point, wow, VRF systems are great and their operating expenses are cost efficient, but they are really expensive on the front end. Well, we're here today to explain how this isn't really the case. VRF systems actually help developers and building owners avoid costs normally associated with alternative methods like PTAX or VAV systems. The characteristics of HVAC systems dictate requirements outside of the mechanical bid that impact the developer's first and total costs. For example, VRF systems allow developers to eliminate sleeves and limit wall penetrations and louver openings, all of which saves on equipment and labor costs. Now let's look into the other benefits of VRF technology that involve first costs. Maximizing the space. So with smaller plenums, many conventional systems require large duct runs to move conditioned air. VRF systems utilize small diameter piping. This allows for smaller plenums, making rooms appear more spacious and enabling architects to reduce the construction costs. In certain applications, these reduced plenum space allow for developers to increase the usable space and even add additional floors. What about mechanical rooms? VRF equipment is compact compared to conventional HVAC and is distributed rather than centralized. This reduces space requirements for mechanical rooms, again allowing for more design space. Here you can see a visual of the usable space saved by VRF. This is the difference in maybe having a rooftop bar or additional tenant space in the building. These are all ways to save money and bring in more revenue at the same time. At an average weight of 70 pounds per ton for an outdoor unit piece of equipment, VRF is up to 30% lighter than alternative methods such as chilled water systems. This reduces requirements for structural steel and beams, saving costs up front. The design flexibility of VRF's system's modular components mean that contractors can finish out a system floor by floor based on the needs of the tenant. This benefit of customization also allows the cost to be deferred until leases are actually signed. So unlike traditional systems, a developer and a building owner can defer costs and the tonnage up front, and then they can build onto a system as needed when the building is finished. Let's go through a first cost saving scenario. The following comparison, based upon a 3-story, 78,000 square foot office building in Wisconsin, illustrates how a developer's per square foot cost for a conventional VAV can actually be higher than those for a VRF system. This is despite the apparent premium paid for high efficiency VRF technology. If we look beyond the mechanical bid, this premium, quote unquote, actually shrinks. As you can see here, the reduced plenum makes VRF the ideal choice for this building based on the first cost. The system delivers HVAC at a very competitive price when compared to a traditional VAV system. For more information on this particular scenario, make sure you go watch the video on our YouTube channel entitled Next Generation Office Building. So now that we've gone through saving on the first cost, let's look at some of the post-development and install cost benefits. Streamlining the maintenance. While maintenance and the associated costs are just a fact of owning a facility, it does not have to be a financial burden or a time suck. VRF offers simplified maintenance once per quarter. A facility manager or a mechanical contractor can clean coils, check electrical connections, check refrigerant lines, and inspect all the other pieces of equipment. Filters are reusable and last up to 10 years with proper care and maintenance. VRF systems also eliminate the complexity of some traditional systems. For example, with VRF, you reduce or eliminate requirements for belt changes, boiler analysis, chiller maintenance, cooling towers, frequent flyer replacements, pump seals, straining cleaners, water treatment, and all those 10-year overhauls with traditional systems. At this point, we understand that VRF has a very precise energy use. The inverter-driven compressors only use the exact amount of energy needed to reach a zone set point. That said, it's a huge benefit for all types of buildings that have tenants. If a building owner bills individual tenants for energy consumption or needs to bill for excess usage, an energy allocation controls panel provided with the VRF system are a huge benefit. This solves the challenge of energy consumption billing from multiple tenants at one time. They can be customized to suit your building's needs. For example, our Diamond Controls custom application panel is a packaged offering that helps you get the most value out of your VRF platform using advanced controls. For office buildings where projected energy use and utility bills are built into the monthly rent, the energy efficiency of a VRF system creates opportunities to offer more competitive leases with minimal impact to the profit. There's also some energy efficiency tools that you can use. One other point we wanted to mention today was in regards to energy allocation and efficiency was the City Multi Efficiency Evaluator. We understand that for many projects, building ownership and developers need to understand how VRF equipment and the subsequent energy use restrictions are going to impact them financially. For this reason, we teamed up with the Wint Group with a tool known as Wilben to create a tool which reliably predicts how a building will perform with the VRF system in comparison to existing alternative HVAC systems. The City Multi-Efficiency Evaluator calculates projected energy use, life cycle costs, and lead points for a building based on multiple factors. The analysis then helps a building owner easily identify efficiency-related financial benefits and is useful when research utility companies who offer other energy-saving incentives are involved. So what about sustainability and competitive advantages? Not all developers and building owners will immediately recognize the benefits of lower bills, reduced maintenance costs, or overall energy use. That said, there are substantial indirect benefits associated with making the effort with the Energy Efficiency Evaluator. We've listed a few stats from our Bensall Kennedy office building portfolio. This study was published in 2015 and pulls 10 years of financial performance data from their office building portfolio, which includes 34 million square feet of commercial space in the US and more than 24 million square feet in Canada. These figures prove that investing in sustainability and green building provide a return on the investment. VRF systems significantly contribute to the certification and marketability of high-performance, sustainable buildings. To give you another example, installing VRF systems significantly bumps up points for LEED certification, which is a well-known and recognized energy efficiency measure in the industry. The energy and atmosphere, as well as the indoor environmental categories, total 28 points, giving you huge steps in various LEED certification levels just by installing VRF. As noted earlier, VRF technology varies in capacity, reducing the energy consumption and costs. The ability is especially applicable for a tightly constructed facility using certified net zero energy or passive house ratings. Traditional systems are prone to short cycling and low load applications. It's also very difficult to achieve green certifications with any conventional HVAC system type. A big factor for us right now is working towards decarbonization. We touched on at the beginning of this presentation, our buildings are changing because decarbonization is a key effort among policymakers, utility companies, and interest groups. Because of this, compulsory and voluntary initiatives are on the rise, ensuring drastic change for our built-up environment. We've already discussed Local Law 97, but other initiatives driving change is the Carbon Neutral Cities Alliance. CNCA is a coalition of cities working together to reduce greenhouse gases and emissions 80 to 100% by 2050 in the US. Working together, cities involved such as Boulder, Colorado, Minneapolis, Portland, San Francisco, Seattle, and Washington, D.C. The point is, building owners and developers need to understand energy efficiency needs to be on top of priorities as the country looks to strategically electrify our society and clean the electrical grid. They should expect financial implications or penalties by not complying with those mandates that are coming up in the coming years. Electric-run VRF heat pump systems will become the preferred heating and cooling method for this compliance. I'm going to pass it back over to James now, who's going to take us through some case studies.
All right, thank you, Tom. So now that we have an understanding of how VRF systems save costs, pre-development and long-term, let's take a look at a couple of case studies. The first one I'd like to share with you is the Nomad Hotel in Los Angeles. Nomad LA is a luxury 14-story hotel with 241 guest rooms in the heart of downtown LA. It has a sister location in New York City, and the hotel's ownership, the Seidel Group, we're hoping to bring that success to the West Coast. Seidel Group's passion is to take unique, typically historic buildings and refresh them with lavish accommodations and amenities. When they bought the historic Bank of Italy building at Giannani Place, They knew installing a modern HVAC system was a must, but they also wanted something very energy efficient. And they were also challenged with limited space, and because the building is historic, they couldn't make very many architectural changes to the exterior. After consideration of multitude of options, Seidel Group went with Mitsubishi Electric's City Multi VRF equipment as the solution. The benefits: a small two-pipe system, no unsightly P-tax, quiet operation as to not disturb guests, and minimal rooftop equipment. Not only does the ownership save money with the system's efficient operation, but they also gain money with the revenue-producing rooftop amenities such as the bar and pool, something that wouldn't have been possible with the traditional system. Nomad LA also met the Cal Green Building Code, some of the highest energy compliance standards in the United States. Seidel Group credits the efficiency of VRF technology in helping to meet this certification, as historic buildings often have a more difficult time meeting this caliber of efficiency standards. Lastly, by having the equipment installed by a Mitsubishi Electric Diamond contractor, Nomad LA received a 10-year compressor and parts warranty, preventing any additional unexpected costs for maintenance and repair. According to Ryan Bean of the Seidel Group, many of the existing city properties we develop are built lot line to lot line. There's no space to build a centralized plant that has cooling towers, boilers, and chillers. VRF was ideal for us because we can put units on the roof that have a small footprint. The next example I wanted to share with you is the Walnut Hill Community Church. Walnut Hill Community Church has a large congregation within a fairly expansive facility in Bethel, Connecticut. The church's HVAC system was very outdated, with 4 32-ton ducted air handling units, a boiler, chiller, and coils. The facilities manager was told they needed a direct chiller replacement since theirs was working at only a 30% efficiency level. However, it would have been astronomically expensive and difficult to take out 4 32-ton air handlers from the building. Ultimately, the mechanical contractor and distributor worked together to specify the Mitsubishi Electric City Multi VRF equipment for the church. Using linear expansion valve LEV kits, they connected the existing air handlers to the VRF manufacturer controls. This gives them VRF operation capability, offering significant energy efficiency for the building. The controls also now offer streamlined management of the new and existing equipment that's been tied in. The mechanical contractor projected the church's cost savings to be about $50,000 per year. Before, they had a traditional 4-pipe system and were continuously running the chiller or boiler to maintain coil temperature. That was costing them a ton of money and was generally a super inefficient way to condition a building. Now they are looking at a 5-year return on investment. Clay Norman is the facilities manager at Walnut Hill Community Church. He stated, "When we started looking at different brands and systems, I asked questions about energy, longevity, and the complexity of maintenance. There was no comparison between the direct chiller replacement and the City Multi system. The 2018 cost is already 23% lower than 2017. That also represents a 23% reduction in usage with an 8-degree higher temperature for 2018. What are some of the takeaways that we've learned today? As we've discussed, there are efficiencies and cost savings associated with VRF technology. VRF systems can reduce and eliminate certain first costs. Installing VRF systems have long-term cost benefits. And the efficient operation of VRF systems can help improve a building's sustainability. Now here are some additional resources I talked about at the beginning, some additional learning opportunities. Here's the Mitsubishi Electric Trane website, metahvac.com. There's also a link here to review some of our newsletters. We have newsletters for architects, engineers, building owners. We also have a number of case studies on our website. We have over 170 case studies, including a lot of applications, including hotels, office buildings, education facilities, and many others. And lastly, here's a link to locate a qualified HVAC contractor or VRF distributor. On behalf of Tom, thank you again for your time and attention today. With that, I'll turn the presentation over to our moderator, Andy, to begin our Q&A. Andy?
Thank you, James. Thank you, Tom. Great presentation, and we have quite a few questions that have come in. Questions from individuals of all different levels of knowledge concerning VRF, so let's get right into it. So to begin, here's a question just about how VRF systems function. This is a question about how branch circuit controllers specifically function. So how do branch circuit controllers move heat to and from the zones requesting it? Is it through the condenser?
Well, as I mentioned earlier when I was talking about the branch circuit controller, it actually connects from the outdoor unit, goes through the branch circuit controller, and uses refrigerant lines to condition the refrigerant using a liquid gas separator, and then it disseminates that to the indoor units. I don't know if Tom would like to add anything to that.
Yeah, it's the same way as that any conventional HVAC system or conventional cooling system would work. It just does the same thing in reverse. And from the outdoor unit to the branch circuit controller, you actually have both phases of refrigerant existing in that branch circuit controller at the same time. So as we mentioned in part of James's presentation was a gas liquid separator, and the units that are in cooling would take the supercooled liquid off the bottom and send it out, and units that are in heating will take the superheated gas and take it off the top and send it out. So the branch circuit controller is sort of the quote-unquote magic box that makes that happen. So it's the same refrigerant circuit with both phases in it at the same time, and whatever needs heat gets heat, and whatever needs cooling gets cooling.
Okay, great. So this next question concerns a critique that this individual has heard of VRF systems. So this person has heard that it is difficult to incorporate building automation systems via BACnet with VRF systems. Can you speak to that issue and how that might be addressed?
Yeah, I'll take that one for sure. So that's something that we've heard as well. But I want to make it very clear to everybody who joined us today. You know, there's 2 or 3 methods now that you could use to integrate a commercial building with a VRF system. Similar to any rooftop or chiller or packaged air handling unit, we have 3 different ways right now where you could integrate a VRF system in its totality to a BACnet building automation system. The first is a standard BACnet license that lives inside of our central controller. The central controller serves up a BACnet over IP connection, which gives you about 33 points per indoor unit of information, and that's both control and monitoring. So you can see space temperatures, you can get mode status, you can get fan speed status, and then you can send commands through your BACnet building automation system to turn it on, turn it off. You could schedule it. There's anything the central controller made by Mitsubishi can do can be done via that standard BACnet connection. If that's too much for your building, we have a Procon module that we've worked with a company called Procon that creates a direct connection on an individual indoor unit basis. This is for those, smaller or light commercial buildings where you just have a few units that you need to get connected to your building automation system. You can connect a little adapter that then runs an MSTP, twisted shielded pair, from the indoor unit to your building automation system. So that's via MSTP. So any of my controls brethren on the phone will know that the difference between BACnet IP is an Ethernet connection and MSTP is a twisted shielded pair connection. The last way is diamond controls. So we mentioned diamond controls in terms of sustainability and energy. We also have several controls packages that increase the level of integration that you can do through the standard MNet. It goes through a diamond controls interface and then can be served up in a multitude of ways, however the automation contractor needs it done. So more than a few flavors of BACnet connections. So please reach out to us if you're having difficulty or one of your customers is having difficulty. Please reach out to us. Get in touch with your local Mitsubishi Electric Trane HVAC rep in your area, or you can always reach out to the solutions team, which is what I am part of, at solutionsales@hvac.mea.com. James, did you want to add anything to that?
No, I think you covered it.
I think you did. There's another controls question coming a little later, but we're going to transition to a general question about the difference between two-pipe systems versus three-pipe systems. Basically, this person wants to know the pros and cons of two-pipe versus three-pipe.
Well, I'll mention a couple things and then I'll let Tom chime in. I mean, Mitsubishi was the first to actually introduce the first two-pipe system, while some other manufacturers have the three-pipe system. And of course, one obvious savings is on the space requirements that, two pipes save versus three pipes. Tom, I don't know if you want to add any additional information.
Yeah, I think we all know that, so Mitsubishi was the first to have a patent on the two-pipe system, which the installed upfront cost can be significantly lower, connections required, piping required, the amount of branch circuit controllers with a three-pipe system actually goes up. So we have larger home run style branch circuit controllers. Some of the other manufacturers have smaller but higher, more frequently used branch circuit controllers. There are a lot of advantages on the installed first cost of using a two-pipe system. And if we have to take our Mitsubishi hat off for a second, you can say that other systems do have some of their inherent advantages as well, but many of them don't overcome that first cost savings that you do see with a two-pipe system.
Okay. This is a question just about the general savings of a VRF system compared to a conventional system. So just generally speaking, what are the typical operational cost savings with VRF versus conventional systems?
Yeah, I know certainly one of the examples we used on the case study with the Walnut Hill Church. I mean, in that scenario, they connected some of the Mitsubishi Electric City Multi equipment to some previous equipment they had, and they were basically able to immediately recognize, I think it was $50,000 in savings over the first year, and we're basically going to see a return on investment within 5 years. I mean, of course, that obviously will depend on a lot of different factors from, how intricate the system design is and the climate and all that kind of information. But I think certainly VRF technology has demonstrated that over the cost of lifetime ownership, if you will, that it's definitely a bigger cost savings in the long run. Tom, I don't know if you want to add anything.
Yeah, no, that's a perfect point. I'll take it beyond the first cost and say that, for a four-pipe fan coil chiller boiler setup, VRF is going to be not only less expensive on the front end in a building of similar size, or if you were going to do a complete replacement, not only are the upfront costs lower, but the operating costs are certainly lower when you're running chillers and boilers and heating and cooling methods at the same time. It's literally what the system was designed to do right out of the factory without burning any fuel, and doing it with an inverter-driven compressors that just meet the need and don't do any more. So yeah, installed cost and so in general answer for a building that fits well for VRF, we've seen 30% savings, for buildings of a similar footprint, 30%, 40% energy savings, and that's been proven in utility bills from customers who have done retrofits. So yeah, absolutely.
Okay. That sounds good. So what's the typical, it's kind of a follow-up question, what's the typical life cycle of a VRF system, and how long will it take to typically see a return on investment?
Yeah, I mean, I think one of the things we've seen with VRF systems, because of the minimal maintenance that's really involved with them. I mean, they don't typically have the additional parts that some other traditional HVAC systems do. So, I mean, from that standpoint, we've seen VRF systems last 10, 15, even 20 years or longer. And as we briefly mentioned earlier, the return on investment, I think, again, a lot depends on exactly what application you're installing the units in, whether you're, connecting additional third-party equipment, types of indoor units used. So I think a number of those factors can answer the really return on investment question.
Okay. Here's a question with regard to, we've received several questions with regard to the temperature range in which VRF systems can operate. So what are the coldest and warmest temperatures at which VRF systems can provide comfort?
Yeah, I'll start with that, and then I'll let Tom chime in. We actually, with our latest City Multi outdoor units, we actually have a tiered product lineup so that we have a standard efficiency, a high efficiency, and what we call a H2I hyperheating inverter technology system. And those systems can actually operate in colder climates down to minus 22 degrees. So those are very, very efficient and very opportune systems that work perfectly in extreme cold weather climates. Tom, I don't know if you want to add anything.
Yeah, no, I think you nailed it. This is always a question we get, when does it shut off? When does it stop working? The actual point where a unit has to turn off to protect itself from being damaged is in the negative 30s with the current models of high heating equipment. So current hyperheat models of the N-Gen are rated to produce. I'm talking numbers that are not committed to memory, so bear with me. I'm going to talk in generalities here, but I believe our current highest heat producing model, the hyperheat N generation City Multi unit, is rated at negative 13 to produce 100% of its rated heating capacity. And I think it's rated down to negative 22 for 70%. So if sized correctly for areas that have the design, your cold design day down that low, you're in Canada essentially before you're designing that kind of day from the last time I saw. So we have units that will work throughout the lower 50 United States year round and provide plenty of heat. We have several case studies of northern climates that are completely sole source of heat pumps, the City Multi equipment, even older generations than the current, and they're working perfectly to this day.
Okay, great. Okay, so this next question is with regard to energy allocation. So this person asks, how do I bill each tenant for electricity in a residential building with the same ODU for similar sized apartments if we can't afford installing a separate ODU for each apartment?
Great question. I'll jump in and take that one. So the City Multi, so if we're talking about a larger system that's serving multiple tenants with a single or a smaller number of outdoor units, and you don't have that one-to-one configuration, one-to-one obviously makes it a lot easier because it's served off of the tenant's, power hookup, and their utility bill just, varies respectively. When you have a City Multi system that's serving multiple tenants, we actually have a system in the software called energy apportionment. Now, this is not a billing software, but what it is it's an apportionment method that looks at how much energy each individual indoor unit section has been using. And if the design is such that an indoor unit or a couple of indoor units are designated to tenant A and a few indoor units are designated to tenant B, you can group those indoor unit sections and say, this is energy block 1, and you can see how much energy they've used month to month. And how that gets done is measurement of the size of the unit, how snapshots of how much the linear expansion valve was open during operation, time the expansion valve was that amount of open, and it's actually calculated. And then at the end, you get an aggregate, and you'll be able to compare it to your total energy use, because to do this, you have to put a dedicated meter on the outdoor unit itself. So in New York City and soon in Massachusetts, this method is actually approved to allow building owners to bill their tenants using an approved billing company, right? We give you the energy apportionment through that, but using an approved billing company, the owner is actually allowed and able to bill their tenants thusly on their air conditioning use and their heating use per the terms of their lease. Huge, huge thing for us in New York City right now. We see it all the time, and my group specifically is involved in a lot of projects like that. So if you need more information on that, please feel free to reach out to us, and we can dig deeper into the details.
Okay. This attendee would like us to take them through how developers can defer some costs. So this would be by installing some units later, or they're wondering, are we just talking about outdoor units, or does that include indoor units?
I'll jump on that one first. Yeah, sure. Sorry about that. Sleeping at the wheel here a little bit. Sorry. Yeah, so that's a great question. So take a multi-use, multi-tenant build. Let's say it's an apartment building that has, a restaurant and a lobby and a coffee shop at the bottom, and they have multiple tenants. So we want, part of its office building, part of its living space. It's a multi-use building. What the developer and the designer can do is calculate the required tonnage for outdoor units, run large refrigerant piping from those outdoor units to those branch circuit controllers that you saw as part of our presentation, and then stub them off, and only use 50% of that each individual system's rated capacity, and run it to those common areas and hallways and the coffee shop and everything that is going to be up and running on day one. And then as tenants come into the space, they can then actually defer some of those fit-out costs to that tenant that's incoming. And a side benefit to that is the incoming tenant can then select how they want their space configured. Where do they want indoor units on the wall to maximize ceiling height? Do they want ducted units to make sure that they hide the air conditioning? It's completely based on the preference of the tenant. So absolutely, it's first cost deference in terms of adding tonnage as needed depending on the use of the space. So adding more units outside, or deferring the cost of the inside fit out based on the tenant's needs. So you can do it in both directions, and we see that pretty often.
Great, thank you. So this next question is with regard to the case study that was featured in the presentation. So in the case study for the church, did I hear that the existing AHUs were able to be reused? Can you explain how that was done?
Yeah, I'll start and then I'll let Tom chime in. Yeah, that's I know the linear expansion valve kit, the LEV kit came up a couple of times in the presentation, but we did reference it in the case study. The great thing about the LEV kit is it's really an interface that allows you to connect the Mitsubishi Electric City Multi outdoor equipment units to air handlers produced by other manufacturers. And then those air handlers can be used with or without City Multi indoor units. So in other words, you're really not handcuffed by having to get new equipment if something is already working in its place. This allows you really to connect your new Mitsubishi Electric outdoor units to air handlers produced by other manufacturers.
I'm good. That was well said. That was well said. So we can. That's what the LEV kit has a huge application for the retrofit and upgrade market, where it's just not feasible cost-wise to get rid of the shell of an old large air handler and you just want to replace the internals and the guts, you can take advantage of a VRF system by just putting in the linear expansion valve kit. Essentially, you're taking advantage of all the benefits of the outdoor unit and the way that it operates, and just sticking it into an old casing. So a lot of applications we're seeing that product come on really strong. It's been a really cool product for us.
And I know in that example as well, one thing I forgot to mention is with that case study, it also allowed for the existing equipment to be tied into the controls that were already in place.
Okay, so this next question is a combination of multiple questions we received that are basically going at the same point. How do we handle outdoor air requirements with VRF systems? How do we deal with fresh air?
I'll jump on that one first, and then. Ooh, sorry.
I was just going to say certainly, a DOAS system is typically installed outside and works with other HVA systems. And as I thought about that, Tom, I know you worked on a project not too long ago that incorporated that as well as VRF technology and control solutions with the Uber case study that we did.
Yeah, absolutely. I'm happy to talk about that one. Sorry about stepping on you there. So there's two methods. There's coupled and decoupled. So even though a lot of times VRF and Mitsubishi and some of our other manufacturer competitors are known as ductless, we actually have several styles of indoor units that are ducted. So very easy in that situation. It's set up just like a typical fan coil that's using hydronics, where you can mix in a certain amount of outdoor air that gets coupled in with a ventilation system. Typically in colder climates, you're having to condition some of that air before it comes in, and your local representative from Mitsubishi Electric Trane can help you calculate the correct amount of air that needs to go in there. So you can just reach out and someone will give you the requirements and what is a good rule of thumb and ranges to be in terms of outdoor air exposure and the temperature of incoming air to a unit. The other method is use any type of indoor unit style from us and have your outdoor air system completely decoupled. And James mentioned our Uber project in Pittsburgh was exactly like that. The VRF units were completely separate physically from the ventilation air that was being brought into the space, but a Diamond Controls package available through us, through Mitsubishi Electric, was used to control and couple those two systems together. So they always knew what each other was doing. They're not fighting, and they're always taking account for what's happening in the space. And then there was a remote graphics user interface for the people who manage the building from Uber's facilities group. So those are the two most typical styles that we see. It's basically coupled and decoupled with a little more attention paid to building automation and controls. Do you want to add anything else to that, James, or was that?
No, I think that was perfect. I did, when I heard that question, I thought of the Uber case study, which, as I mentioned, and some of the additional resources you can find on the website.
Yes, sir.
All right. So this next question, we've got a lot of questions about this. Where can someone access the the efficiency analysis tool that we mentioned during the presentation?
So that is something that's going to be used probably by a representative from a VRF manufacturer like ourselves. So what you'd want to do is you would want to reach out to your local Mitsubishi Electric or other VRF manufacturers representative in your area. So a sales engineer would have access to that tool through our company, and they would be able to help you on your project do that efficiency analysis. Definitely want to get someone from our team involved.
Okay. Next question. What kind of maintenance does a VRF system require? And can you talk about the cost?
Yeah, I can start with that one and let Tom finish if he has anything to add. Really, the great thing about VRF systems is it really requires minimal maintenance. I mean, if you look at it really, I think Tom had it in one of his slides, talked about really the only regular thing you really need to do is change the filters and clean the coils on the fan coil units. Basically do that quarterly. I know the filters are reusable and they can last up to 10 years. We also have another tool that we really didn't talk about too much in the presentation, but there's a maintenance tool that you can actually, it's basically an oversized cell phone looking device that you can actually plug into a city multi-outdoor unit, and it can run various system overviews. It can troubleshoot any issues. The information can be stored on an SD card, so if you don't have a laptop handy on site, the maintenance tool will basically store all of that device until you can get back to a PC to download the information. So those I think are some of the key benefits regarding maintenance, are the limited cleanings of the filters and coils that you have to do, as well as the maintenance tool software that allows you to check the system overview and what's working, or troubleshoot any issues.
Yeah, I'm going to add to that. So just not only that, and the maintenance tool, while you are able to connect to it physically at a job site, we talked a little bit about controls. We just released a product that is our first cloud-connected, commercially available control panel, which would give you that maintenance tool information via the cloud. So you did not have to always have that maintenance tool piece next to your outdoor unit. It's certainly there and available for anyone who wants to use it, a contractor or owner who wants to get involved to that level. But the Building Connect Plus available from us is a cloud-connected means that's mobile-enabled and web-enabled, and you would get all of that preventative maintenance type service and troubleshooting data for your system via the cloud. So if you're interested in hearing more about that, please reach out to your rep. But absolutely, I grew up in the automation world, and being part of a team that had to troubleshoot and take care of large, cooling towers and hydronic systems. There is just a ton of maintenance, and someone, one or multiple people for large buildings are needed, week in, week out to care for those systems. Comparatively, VRF has a very low maintenance cost and labor associated. If installed properly, for the life of the system, it's basically cleaning coils and filters and keeping an eye on it for damage. One of the other things you could mention is, snow removal in areas where snow can build up. But even then, units are up on stands and have snow shields. So it's pretty maintenance free compared to other conventional systems on the market.
All right, so this will be our very last question, and Tom, I think you'll enjoy it. Can you elaborate on how I could use VRF controls to better control my costs?
Yeah, absolutely. So right out of the box, even without any of the diamond controls or BACnet enabled things that I mentioned earlier, there's a really robust and good control system for scheduling and maintenance of your temperatures. There's ways that building owners can limit how high or low an individual unit can be set. You can make sure the CEO has free range of temperature control in his office, but everyone else out on the floors and in other spaces are kept in a box, so to speak, in terms of how much they can turn their unit up or down, thereby, eliminating some energy costs there of someone setting it to 80 and leaving their windows open and leaving for the day. All the way up through a built-in BACnet-enabled Niagara-based controls, which we offer to integrate to an existing building automation system that's there, or provide a full turnkey building automation system for your building. And like I mentioned, the cloud-connected method that we have now for it's really aimed at commercial and light commercial projects. There's a lot of different options. So again, I've said it a bunch of times, but reach out to your local rep who can help give you all the details. MyLinkDrive.com is a great resource. All of our engineering manuals and spec sheets are there, and our YouTube channel. Our YouTube channel is fantastic. There is a lot of how-tos and whys on there in terms of how the systems operate and can save a building owner money. So appreciate everybody's time.
Yeah, I'm glad you mentioned My Link Drive. That really is a great resource for getting specification information, marketing information on indoor units, outdoor units, legacy products that might require, looking up a maintenance question. So I'm glad you mentioned that at the end. My link drive is really a great resource.
Okay, so I think that's the last question.
All right, thanks, Andy. Appreciate it. We had a lot of time for some great questions coming in, so I appreciate everybody's efforts on that. Thanks, Tom, for your time today. We hope everybody on the call found the information useful. And on behalf of ASHRAE Journal, thank you for joining us today, and have a great day.